Hi everybody. So I'm going to make this video so that we can go over section 2.5, which is solving equations with variables on both sides. The only difference between the equations that we've been solving for the last several days and the equations that we're looking at today are that there are going to be variables on both sides of the equal sign in these equations. So here's what I mean by that. If you look at example number 1, there is, if we draw our line through our equal sign and we look at the terms that are on the left and the terms that are on the right. On the left side, there's a term that has an x in it, and there's also a term that has an x in it on the right side. What that means is that in order to solve this equation, we're going to need to get all of the terms that have x's together on one side. So the number one rule for today is going to be to move all terms with variables to one side. Now what we're going to find is that it does not matter whether we move all of those terms to the left side of the line or all of those terms to the right side of the line, as long as they all end up being together. So let me show you an example. In this example right here, I know I want to get x by itself, but since there are terms with x's on the left and terms with x's on the right, I'm going to start by getting all the x's together. So in order to get the x's together, I'm going to start by subtracting the 4x on both sides. Now the reason I'm subtracting is because the 4x, which is on the right side, is positive. And to undo a positive, we would subtract. So below there, I'm going to draw my horizontal line and I'm going to look at what happens. Because I subtracted the 4x, the 4x cancels on the right-hand side. On the left-hand side, if I look at what I have left, I notice that the negative 8x and the negative 4x are like terms. They both have x's. So I'm going to drop down the 7, just drop it like it's hot, don't change anything. And then when I combine negative 8x and negative 4x, I get negative 12x. Now on the other side of the equation, I'm going to drop down the negative 17. Just drop it like it's hot. From here, this looks a lot like the problems that we practiced solving the other day. So my next step here would be to subtract 7 on both sides. When I subtract 7, on the left-hand side, the 7's cancel, and I get negative 12x. On the right-hand side, negative 17 minus 7 would be negative 24. Now the last thing I need to do is to get the x by itself is divide by negative 12. And I'm going to divide by negative 12 on both sides of this equation. So, on the left side, the negative 12 cancels the negative 12. I'm going to write this on the side. And I just get x on the left side. On the right side, negative 24 divided by negative 12 would be positive 2 on the right side. And that would be my answer. So let's take a look at another example. So in problem number 2, I would start by drawing a vertical line through my equal sign. Now in order to get the x's together, I'm going to subtract 2x on both sides of my equation. So I'm noticing that on the left side that I can combine the 5x and the negative 2x. And on the right side, the 2x and the minus 2x cancel. Which means I'm just going to drop down the 13, don't change anything. 5x minus 2x would be positive 3x. And on the right side, I would get negative 8. Just drop down the negative 8. Next, I'm going to subtract 13 on both sides of the equation in order to start getting x by itself. The 13s would cancel, and I would get 3x equals. Now I'm going to combine negative 8 and negative 13 and get negative 21. Last but not least, I would divide by 3 on both sides of the equation. And I would get x equals, because the 3's cancel, so I would just have x equals negative 7 as my final answer. Basically, this first step is the only new step for today. Once we do this first step, we get an equation that looks the same as the equations we were solving earlier this week. Let's look at another example, number 3. So I'm going to start by drawing a vertical line through my equal sign. Now this problem is a little bit different because when I look at the terms, there are m's on both sides of the equation. However, the right-hand side doesn't have any other terms besides the term with the m. So when I'm trying to decide how to get the m's together, instead of subtracting 5m, I'm going to add 3m. And the reason I'm going to do that is that let's say I did subtract 5m on both sides, there would be nothing left on the right-hand side because the 5m would be gone. So rather than end up with one side of my equation having nothing left, I'm just going to move the 3m instead by adding it. So when I add 3m, the 3m cancels, which means I get 24 equals. On the other side, I get 5m plus 3m, which is 8m. And then I divide both sides by 8. Now when I divide by 8, the 8's cancel, and I just get m. 24 divided by 8 is 3, and that's my final answer. Now let's look at some problems where you would be allowed to use a calculator to help you solve them. So let's take a look at example number 4. Example number 4 is about as complicated as it gets. It really combines everything that we've learned so far about solving equations. Now yesterday we learned that in an equation like this where there's a parentheses, step number 1 is going to be to distribute. So when I distribute on the right-hand side, I get positive 6z minus 8. All I'm going to do on the left-hand side is drop everything down. Just drop it like it's hot. So I get 5z minus 2. Now I notice that I have an equation where there are variables on both sides. So my second step would be to collect the variables. In other words, I want to get all the z's to be together. In order to do that, I'm going to subtract 6z on both sides of my equation. When I do that, I'm going to combine the 5z and the negative 6z on the left-hand side, and I'm going to get negative 1z. Then I'm just going to drop down the minus 2. On the right-hand side, the 6z's cancel, so I'm just going to drop down the minus 8. Next, I'm going to add 2 on both sides, which means I get on the left side, the 2's cancel, and I get negative 1z. On the right side, negative 8 plus 2 would be negative 6. Last but not least, so I'm sorry, I should write that down. Then I added 2 on both sides. And the last thing I'm going to do is divide by negative 1. So I ran out of room a little bit. My answer would be, on the left side, the negative 1's cancel, which means I would have z equals, on the right side, negative 6 divided by negative 1 is positive 6, and that would be my final answer. Let's take a look at another example, number 5. So I would draw a vertical line through my equal sign. And now my first step is going to be to distribute, just like before. When I distribute the 1/4, I could use my calculator, or I could just think about this as dividing by 4. Either way, I get 4x plus 15 after I distribute. And I'm just going to drop down the 9x minus 5, just drop it like it's hot. Now I want to get all the terms that have the x's together. So I'm going to subtract 4x on both sides. On the left side, I notice that I can combine the 9x minus the 4x. So I get 5x. Now I'm also going to drop down the minus 5. On the right side, the 4x's cancel, and I'm just going to drop down the 15. Now I've got to get x by itself. So I'm going to add 5 on both sides, which means on the left side, the 5's are going to cancel, and I'm just going to drop down the 5x. On the right side, 15 plus 5 would be 20. Last but not least, I'm going to divide by 5 on both sides. And I would get, on the left side, the 5's cancel, so I just get x. And on the right side, 20 divided by 5 would be 4. And that's my final answer. So if you look back at these two problems, really this is a combination of all of the different solving things that we've learned so far. Distribute, move the x's, get the x by itself. Let's take a look at probably the most complicated problem. So the good news is number 6 is really truly as hard as it's ever going to get. So let's take a look at number 6. I'm going to start by drawing a line through my equal sign. Now I'm noticing that I'm going to need to distribute on both sides of this equation. So I'm going to distribute the negative 3 and I'm going to distribute the negative 4. When I do that, I get negative 3m minus 21 equals, on the other side I get negative 4m minus 24, and then I'm just going to drop down the minus 2m and don't change it. Now I'm going to look for like terms. So on this problem, on the left side, there are no terms that I can combine, but on the right side, I'm noticing that negative 4m and negative 2m are like terms. When I combine those, I get negative 6m, and what I'm going to do is just copy down the rest of the problem and not change anything. We're going to do one step at a time. Now this problem looks a lot like the problems that we were doing earlier. So we're going to get the m's together next. So I'm going to add 6m on both sides. When I do that, I'm going to combine the negative 3m and the 6m, which gives me 3m. On the right-hand side, the 6m's are going to cancel, and I'm just going to drop down the minus 21 and the minus 24. Next, I'm going to add 21 on both sides in order to start getting m by itself. So on the left side, the 21's are going to cancel, and I'm going to drop down the 3m. On the right side, this should be a 21. I don't know what I wrote. Hold on. This should just be a 21. Oh. Okay, fixed it. So negative 24 plus 21 would be negative 3. And then last but not least, I would just divide by 3 on both sides. And on the left side, the 3's would cancel. So I would just have m. On the right side, I would get -1. Okay, so that's the new solving that we're doing today. Let's take a look at one other type of problem we need to be aware of. So it turns out not every equation has an answer. Sometimes we have an equation that is what's called an identity. An identity is an equation that is true for all values, and it's called an identity. So you would know you had one of these special types of equations because when you tried solving, all of the x's would cancel, so all the variables cancel, and at the end, all you're going to have is numbers that are true. For example, 3 = 3, which is true. Now you're going to know that you have a problem that has no solution because it's an equation that is never true. So identity is an equation that's always true, and no solution is an equation that's never true. Once again, all the variables are going to cancel. But when you get to the end and you just have numbers, you're going to get something that's false, like 3 = 0. Since 3 never equals 0, you would say that the problem has no solution. So let's take an example of one of each here. Let's take a look at A. In problem A here, we would start, according to what we've learned so far, by distributing. So 3 would get distributed, and we would get 3x + 12. On the other side of the equation, we would just drop down the 3x. Now we're going to try getting the x's together. So we're going to subtract 3x on both sides, which means on the left side, the 3x's are going to cancel and we get 0. And on the right side, the 3x's are going to cancel and we get 12. We're just going to drop down the 12. In this problem right away, I'm noticing all the variables canceled. I'm also noticing that this is not true. 0 does not equal 12. So my answer here would be that this equation has no solution. Now let's take a look at part B. So in part B, once again, I would start by distributing. When I distribute, on the right side, I get 2x + 10. And on the left side, I'm just going to drop down the 2x + 10. Now I'm going to try to get all the variables together. So I'm going to subtract 2x on both sides. And the variables are going to cancel on both the left side and the right side. So my final answer will just be 10 = 10. Well, right away I notice all the variables canceled. So I know something different kind of is going on here. It's one of these special types of equations. However, this time, this is true. 10 really does equal 10. So we would say that this equation is an identity. All right, we're going to go ahead and stop there for today. Your job now is going to be to work on your homework. It's out of your textbook, so feel free to take out your Chromebooks and get started, and I will see you tomorrow. Thank you for listening and have a great day.